In this experiment, we will see the magnetic effect of the current. When electric current passes through a wire or a coil, it produces a magnetic field. What do I mean by that? If I bring a compass needle or another magnetic needle, it will get deflected if the magnetic field is there. Magnetic field is generally produced by magnets. I have so many magnets. This is one. Now around this magnet it has created a magnetic field. You bring a compass needle and it will get deflected. That is the test of magnetic field. But can you produce magnetic field without a magnet? Yes. See, here we have a coil. This is a coil. You take enameled copper wire and give it 25 rounds or 40 rounds or 50 rounds and make a coil. And then at different places, after giving all these turns, you put these sellotapes so that the coil is intact, and then put it on some plastic cover, any plastic cover or wood cover, and I have fixed it vertically perpendicular to the cover with this M seal. You can put sellotape also here if you like, so that this coil is fixed. It should not be loose. It should be rigidly fixed to this base cover. Now, so that is the coil part. You have two ends of the coil. So these are the two ends. You take out the enamel at the ends so that electric connections can be made. Now you have this magnetic needle. What kind of needle is this? A sewing needle. I have magnetized it and then I have put it with the help of this thread. It is suspended at the center of the coil. So how do I magnetize it before putting it here? I have to keep it somewhere and then take a bar magnet and then rub this needle. How do you rub? Place a pole, rub it till the other end, lift it. Again put the same pole at the same end, at the first end, rub it till the end and lift it. Remember, don't have to change the poles in between. You have to rub only in one direction, not left and right like this. Don't do this. It will not get magnetized if you do this. This is not the way. You have to rub only in one direction. When it reaches end, you have to lift it. Okay, then I have this battery. This battery is to pass current in that coil that we had made. In this battery, 1.5 volt Eveready battery, and from the two ends I have connected two wires, these two wires, and at the end of the wires I have put these clips so that it can be connected to the coil easily. So now these two clips connected to the battery, we are ready to put it to the coil. Okay, can easily make this all connection. Now I am connecting one end of the battery with one end of the coil, and the second end I am not connecting permanently. I am touching and removing. See, I am touching the other end of the clip and removing, and see the needle. As I touch, the needle gets deflected. See, the needle is dancing. It's dancing. Why? Because I am sending the current, and not continuously. I am sending it momentarily, and then I am removing it so that current stops. So every time I give the current, it deflects. Now I have removed the connections. No current is going in the coil. Now if no current is going in the coil, in which direction the needle is standing? It is in south-north direction, because it is magnet. Magnet always stays in north-south direction, you know that. Let me rotate. What happens now? Which direction the needle is pointing? It is again pointing north and south. It has not rotated with the coil. In whatever way I keep the coil, the needle is always north south. Now let me pass the current. Now I am connecting. I connected one end, and this time permanently connecting the other end. I connected the other end. Now the current is going continuously in the coil. See the direction of the needle. Is it north south now? No, it is east west. How come? A magnet staying in east west direction. Okay, let me rotate it. Rotate the coil and see whether this magnet has forgotten east, north west, north south. Always remains east west. No, now it is north south. It is rotating with the coil. Earlier when there was no current, it always pointed north south, but now it is pointing perpendicular to the coil. Whatever way you put the coil, the needle will be always perpendicular to it. See, you can put it in north south, you can put it east west, you can put it in between the two. Whichever way you put the coil, it is perpendicular. Needle is perpendicular to the plane of the coil. So why it is happening like this? Because you have current in this coil. Current is going in this circular coil. It is creating a magnetic field perpendicular to the plane of the coil, and it is a strong field. So the Earth's magnetic field is negligible. This is main field is because of the current in the coil, and that is always perpendicular to the coil, to the plane of the coil. Whatever way you rotate the coil, the field is perpendicular to the plane, and the magnetic needle stays there. So current produces magnetic field, and a circular current produces magnetic field in a direction perpendicular to the plane of the coil.